Atoms are divided into two major parts: a centrally located nucleus that contains positively charged protons and uncharged neutrons, and one or more orbitals, regions in the space surrounding the nucleus in which negatively charged particles, called electrons, travel about continuously at nearly the speed of light. Protons and neutrons each have a mass approximately 1,836 times greater than that of electrons. However, in spite of the huge difference in mass between protons and electrons, their electrical charges, though opposite, are equal in magnitude. As atoms have equal numbers of protons and electrons, they are electrically neutral. Every element has a unique atomic number. The atomic number of an element corresponds to the number of protons found in the nuclei of its atoms. For example, hydrogen atoms have one proton and an atomic number of 1. Helium atoms have 2 protons and an atomic number of 2, while carbon atoms, which form the atomic skeleton of all the larger molecules found in living organisms, have 6 protons in their nucleus, giving them an atomic number of 6. While every atom of a given element has the same number of protons, the number of neutrons contained in the nucleus of atoms of the same element can vary. For example, carbon atoms can have 4, 5, 6, 7, 8, or 9 neutrons. Each of these different forms of carbon is referred to as an isotope. Isotopes of a given element like carbon are virtually identical to one another in terms of chemical reactivity, but sometimes vary in their physical properties. For example, the nuclei of some isotopes, called radioactive isotopes, spontaneously disintegrate, releasing radiation in the process. In the case of carbon, the isotopes carbon-12 and 13 are stable, while carbon isotopes 10, 11, 14, and 15 are radioactive. The existence of radioactive isotopes in carbon and other elements allows scientists to carry out tasks as different as dating the fossil remains of long-dead organisms to studying the physiology of the human mind. However, it is the behavior of electrons in an atom's outer orbitals that determines how the ions and molecules critical to life are formed.